Okay, I'm back. This segment is trying to figure out the number of fractures per meter along a borehole. In real life, you probably have one or more boreholes where you're measuring the number of fractures per meter. You want to see if you did a good job of that by creating this DFN. Note that the logic that's built in here is measuring the fractures per meter of the original fracture set that we created, the discs. It is not measuring the number of fractures per meter in the 3DEC model. So if we go back up here where we created the DFN, we can just restore that state, not worry about the 3DEC model for now. You would probably do this kind of analysis before you spend all the time cutting up your 3DEC model. Make sure that you've created a realistic DFN. So we'll go back to the DFN. So you might be here, and the command I was searching for before I say fracture, it's actually fracture compute. So if I hit control space now, there's fracture, there's compute. There are different things I can compute, but what I'm looking for is this P10. I can right click on that and insert selection. And then I can give a beginning point and an ending point, and it will just calculate the number of fractures per meter between those 2 points. Alternatively, I can give a geometry, and I'll talk about that in a minute. But for now, let's give a starting point. So let me close this. The beginning point might be, for example, 0, 0, minus 40. Remember that our domain extent was minus 50 to 50. So if I start at 0, 0, minus 40, and I end at 0, 0, 40, typo, there. We just run this line. Tells you for DFN number 1, the P10 is 0.0625. So this is not a very dense fracture network. There's less than 1 fracture per meter in this case, which is fine. But probably what you want to do in reality is be able to visualize the line where you're doing this measurement. Now, you might have boreholes as DXFs, and you can just import them as geometries and plot them and do this calculation. I don't have a DXF borehole here, so I'll just create one on the fly. And I can do that with commands. So I can say something like geometry, edge, create. And again, if I can't remember how to create an edge, I hit control space, and I can say by positions. I just give the positions of 2 points here. So I can use the same coordinate, 0, 0, minus 40, 0, 0, 40. So this just creates the geometry, and then I want to measure the P10. So I take the same command, copy and paste. But instead of giving a begin and an end, what do I need to give? I need to say geometry. Oh, and then I need to specify the name of a geometry. So when I create the geometry here, I need to give it a name. So I say set VH1. So for borehole 1, let's say. And then when I measure the P10, I need to give that name. So I say geometry VH1. Let's see what happens. I run these 2 lines. It creates the geometry, it measures P10, and I get the same answer. It's 0.0625, which makes sense, of course. But now with this geometry, I can go and visualize it. So if I go to my DFN plot, I'm already showing a cross-section here. Let's pretend, let's make a new plot just so you can see how I created that. Here's a new plot. So I have my fractures. Here they are. I can add my geometry. Here it is. It's just one edge. By default, this geometry will probably come in blue for you. I changed it to reds, and it remembered that. So, but if you want to change the color, you can go over here to where the color list is and the geometry. Change it to something else. Just for fun, we'll make it pink. It's a bit hard to see in there. You could take your fractures and make them transparent. Maybe you can see a little bit better where your borehole is. Alternatively, you can make a cut plane. So let's reset this plot to the XZ plane. And under fracture, I can choose cutting tool, and I'll make a cutting plane here. So I can see the traces of the fractures on this cutting plane. Here's my borehole. It's 80 meters long. Remember, we went from -40 to 40. I could count the number of fractures that it hits: 1, 2, 3, 4, 5, 6. I could take 6 divided by 80. It's probably maybe a couple more than that because there might be some out of the plane that you're not seeing here. But you could probably convince yourself that this measurement of P10 is approximately correct. And you can do the same thing for different boreholes in different directions to make yourself feel good about the DFN that you generated and whether or not it represents reality. Okay, that is the end of this tutorial. Thanks for joining.